Okay, thanks to all of our panelists for being here. I will introduce them all right now. So we have Brandon Stewart, who's a professor of sociology at Princeton. We have Daniel Rock, who is a professor in the OID department at Wharton. We have Xiao Ma, who is a software engineer at Google, and Payel Das, who is a researcher at IBM Watson Labs. So a really exciting panel, I think, an interesting group of people to talk about generative AI and large language models, because you're all doing some amount of, some work on this topic, in some cases a lot of work on this topic, but I think from really different perspectives. And so I think we'll be able to answer a lot of different questions and think about things from a lot of different angles. We are live streaming this Fireside panel, and so we'll open this up to questions from the audience later. And if you're on the live stream, you also have the ability to ask questions that I will get on this iPad. So feel free to do so if something comes to mind as we're talking, but we'll just have a little chat up here first. And so I thought a good way to just start the conversation before we get into any of the specific talking points is for each of you, I'd just love to hear a little, almost like summary statement of what types of things have you been thinking about? What do you think is interesting? What do you think is challenging about generative AI? For the topics and the areas that you tend to work in. So I guess, Brandon, I'd be curious if you could get us started.
Yeah, absolutely. So I'm in a sociology department, and I do work on methods of causal inference and a lot of work on applied natural language processing. And I think everyone doing work in this space has been trying to figure out what to do with LLMs in the last 12 months or so. And I think I've sort of settled on the idea that I'm really trying to think about this in three ways. We can have a class of things where we interrogate the LLMs, and we sort of say what can this tell us about culture or society, or the biases or the accuracy of the LLMs, all these kinds of things. We can integrate the LLMs into our workflows to do the kinds of things that we were already doing, like document annotation or categorization, and maybe we can do that more accurately. And then we can innovate to do new kinds of things that we couldn't do before, like run different kinds of experiments with, say, levels of personalization that wouldn't have been feasible prior to that point. And so I'm still in the sort of that interrogate, integrate phase, and sort of looking around for the innovation possibilities. But I think it's a process.
Yeah, and we'll talk about all of those things more, because I think, especially for this audience, a lot of really interesting questions about how LLMs can affect experimentation. Daniel, I guess, do you want to similarly give just a quick little blurb on how you've been thinking about things?
Sure, yeah. So I started thinking about large language model impacts from sort of a labor market perspective. Which tasks in the economy are exposed? I'm sure everyone's seen in the press that large language models or generative AI are going to take away all the jobs. If they've cited our paper on that, it makes me want to pull out whatever leftover hair I have. It's definitely not what we were finding, but we do see kind of a lot of broad-based impact, a lot of potential job change. Actually, one of the things that a reviewer suggested, actually, so if you're in the audience, thank you very much, was to look at, within the definition of what general purpose technologies are, the sorts of things that really change how work works. Where do we see the most levels of exposure by job cluster? And the thing that really made me excited when we looked at that information was it's all the research and development and technologists and even teacher roles, the things that are responsible for building and deploying human capital in interesting ways. That's the stuff that's most exposed to these models. So I've been thinking a lot lately about where large language models and generative AI can affect science, kind of to echo Brandon's comments. I think there's a ton of opportunity there, questions that don't even make sense without this technology. So that's going to be cool.
Yeah, and I think some of the talks that we've seen that are LLM related in the parallel sessions are starting to think about, in your paper, you just have a measure of exposure, but it's not clear that all of these jobs that are exposed are actually being changed yet. And I think a lot of these talks are looking at, what implementations of LLMs actually change jobs and in what ways, and what are the optimal implementations. There's so much interesting research to do on that front. So excited to dig more into this as well. Xiao, I guess similarly, do you want to just quickly, let people know what you've been thinking about lately?
Yeah. I guess I should start by prefacing everything I say is my personal opinion, and I'm here in my personal capacity. With that out of the way, my day job, I work on responsible AI team at Google, in particular some of the BART safety and mitigations, and in addition to some of the longer term research in this area. And then on the side, I'm also a part-time artist, and I'm involved with a lot of the artist communities and nonprofits in New York City. And then I think there is also, in general, this energy of trying to figure out the use of these technologies, but also this fear of like, what does it mean? And I think trying to balance that energy and the fear, and also the capabilities of these technologies and the responsibility and the safety and inclusion of these models is something like I constantly try to find a balance.
Yeah, tons of interesting stuff to dive into there. There's a really interesting talk in one of the parallel sessions yesterday about human favoritism in AI, and the notion that, you know, the inverse of algorithmic aversion, but in some cases humans just prefer something that they know has been generated by a human. And you can imagine that being particularly true in more artistic contexts where, you know, we're not necessarily trying to produce as much value as possible, but, you know, the thing we're looking at or interrogating is about the human experience. And so thinking about how AI fits into those types of questions is really interesting. And then Payel, yeah, I guess similarly would love to just hear some of your initial thoughts and how you've been thinking about this.
Yeah, so also a disclaimer, I'm here on my personal time, and everything I say is based on my personal experience and thought. I lead a team in IBM Research AI. I'm a principal researcher there. We are in the trustworthy machine learning, machine intelligence group. And as the name says, before even large language model, the term itself appeared, we have been doing research on how to make the deep learning algorithms in particular more trustworthy. And that naturally took us into the generative AI era, where we worked on algorithmic innovation of different generative AI algorithms. And naturally, as like our others, we have been also doing the research on the large language model. You know, and one specific area that me and my team, we have been working on is how to make these algorithms, these models more controllable. Because a lot of deficiency, a lot of caveat that we see, not just for large language model, but any generative AI is because we do not have the understanding of how to control them. So for the past few years, we have been working on coming up with better algorithms to control these models and also test that do this control mechanism we are putting in place to really work. And in that process, we have been lucky enough to be able to run some end-to-end verification study where we impose some control mechanism on the generative AI side, and then we see what it comes out and ask the expert to verify it. So just to have a more quantifiable assessment of what we added as a control mechanism, is it really working, and where it is not working, and what would have been done by a human or by an expert team if they were supposed to do the similar thing. So I think the same notion is still applicable, and that is something we are working, that how to, like we do know here that by different prompt, this large language model can change direction, their output. So I think the future is here, that how we have a more of a control and the understanding of that control from the algorithmic side on this model.
Yeah, super interesting. I guess one topic that comes to mind on this question of control of the algorithms and their outputs, and I think this probably touches some of the work that all of you have done. Like Brandon, I know you have a paper that looks at using annotations that are generated by LLMs in lieu of annotations that are created by human annotators. And if I recall correctly, the idea of that paper is that, there's probably some bias due to misannotation from the LLMs and sort of how to properly account for that in inference. But I imagine for many of us in this room, there are ways that we could use these models to augment the analysis that we're doing of current experiments, right? So not even integrating LLMs into the experiment design per se, but just saying, I've run an experiment where there's a bunch of text, there's a bunch of rich behavioral data, and I can use these models to try to extract some insights that would have been either impossible previously or very expensive with human RAs or something like that. But in order for that to be viable, we kind of want the outputs of the models to be as high quality and understandable and non-biased as possible, and that's really tough. So I guess I'm curious what thoughts you all have on just what we need to do in terms of understanding what the models are doing, sort of verifying the outputs in such a way that more folks in this room can maybe feel comfortable using these models as tools in their data analysis pipelines?
Yeah, I'll be happy to start with that. So I think this is like an interesting, so very early, like 10 years ago when I started writing about text as data work, I was very critical of closed source models. And it was easy to be critical of them because they were bad. And so you could just be like, you should just do open stuff. And also it's better. And I think one of the places we're at now is that the closed source stuff is like too good to ignore. And that it's changing so quickly. So when you sort of say like, okay, we want it to be as accurate as possible, we want to kind of know the nature of the errors it makes, the problem is that's like an incredibly difficult moving target. And so the approach we took in the paper you mentioned, which is a paper with my former student Naoki Agami at Columbia, his grad student, and my current postdoc, we introduced this framework we call design-based supervised learning, which is basically a way of using sort of double machine learning type techniques to take a small gold standard sample and use it to correct the inferences that you get from the LLM annotations. And the logic is we don't have to know anything about the LLM itself because we have chosen to focus on a particular kind of estimand. We're in the world where what we want to do is we want to annotate a bunch of documents, and then we want to calculate some downstream regression or aggregation on those things. So you could think about something like you run an experiment, you do an open-ended survey response, you want to code some variable from that. You don't care about any individual annotation. What you care about is that average treatment effect or that aggregate estimand. And it turns out that like if you're in that setting, once you focus on that, you can design debiasing measures that are going to work kind of regardless of how the like LLM accuracy is. And that's really, really attractive because it means that we can just plug in the next thing that comes out and still have a result that's like stable and helpful. And as these systems get better and better, we don't have to keep going back and sort of repeating the process over and over again. I mean, we're still obviously going to want to study these systems, but we're at a place now where the pace of movement is so fast, it's kind of hard to wait for the normal like tire kicking that we would do in the social sciences on these systems.
Yeah, the pace of movement question is very interesting. Want to circle back to that in a moment. But I guess before we do that, so Daniel, you have worked on a project where you've used LLMs for a ton of annotations, right? So in addition to studying LLMs, you used LLMs in that project to do the studying of the LLMs. And so I guess I'm curious in practice, surely these questions came up of, how accurate are these annotations? How do we think about them? So how did your research team think about that when you were working on that paper?
Yeah, so originally, we'd done similar studies. Just to give everybody a little bit of background, what we do is we take the 20,000 or so tasks that the government says people do in the US labor market, and then we have some rubrics that we score those tasks on. And those scores come from both human and machine annotations. Now, we'd done it with humans before, and people were kind of fine with that. And when we set out to do this project on LLMs, we kind of thought the human annotations were going to be the baseline one. And then since GPT was really cheap to do it and it kind of worked, we figured this is a nice robustness check. Let's see if we get similar responses. And when it first came out, most people were kind of fine with that. And then some people were like, I can't believe you used GPT-4 to rate GPT-4. This is complete bullshit. And now, 6 months later, I'm seeing tons of studies that use GPT-4 for precisely this sort of work. And everyone's kind of flipping their, well, how accurate are humans really? It's totally turned around because the progress of the model has been super fast. And everyone's kind of finding like, oh, hey, yeah, you can replicate all sorts of social science experiments using GPT-4. So I think it's a tremendous tool for labeling things. One of my favorite little tricks lately, too, is to use GPT-4 to generate like a label for some input data, whether that's text or an image or even tabular stuff. And then you get this training set off the GPT-4 label, and you can train something that's much faster to do inference, like, I don't know, cat boost or something to predict that label. And now you've got logits, and it's the usual kinds of supervised learning things. So you can convert unsupervised problems into supervised problems with this. And that's kind of nice. Now, when you think about, if it's not meta, it seems lately like meta in the work, then it seems like I'm doing something wrong. But we use large language models to study changes in the labor market too, going in the other direction. And I think what we're finding there is the closer you can stay to embeddings, like staying within the unsupervised world of like these factors that are moving around, the more traction you can get on like measuring some sort of outcome that represents change. And then the challenge is interpretation at that point. So we can talk more about that, but I think much is made of these decoder sides of the model where we produce text or code or images, but not enough is made of the encoders where you can represent really unstructured data in numerical formats that are, we can do normal operations on that.
Yeah, super interesting. And so I guess both of these approaches are kind of, I have the data from the LLM. Let me now sort of think about, how trustworthy it is. I guess, Payel, you were talking about, how do we, within the guts of the model, make sure it's accurate. And then, Xiao, I know you've worked on sort of biases that are embedded in the models that, that's one particular type of inaccuracy that we might care about. And so I'm curious how your work that you've done on this topic maybe squares with some of these, these other approaches we've heard about.
Yeah. So just listening to some of the discussions about your research and how you use the language model also is very inspiring to me. I think the way I think of it is there's two parts to the problem. One is how do we improve the foundational models to make it more capable, more accurate, more grounded, and also to do as best as we can to mitigate some of the potential biases or lack of diversity in these models. So that's like a lot of the work that we do is to try to make these base models be better, so that people can trust it more and more. And also when people depend on it, it is actually accurate and does not induce downstream harms. But there is also another aspect of it is like how people are using it. I think a tool does not need to be perfect for it to be useful. But if there is a gap between how people perceive its capability, between that and its actual capability, that's where a lot of my concerns actually come from. Is not that the fact that people use these tools to do a bunch of labeling or checking, but it is because when they use these tools, some of the use cases, if that is a blind spot that we don't know that the model actually has some limitations, and people blindly trust it because it's so good at some of the other capabilities. Yeah, so that's kind of where I get most worried. It's like these models have great capabilities for certain tasks, and you see people using it and as legit use cases, but then you have other people coming in and like, okay, can we maybe then use this to do, instead of labeling, to do user interviews? And that's where a lot of these problems of like agency and you're actually representing the people that you want to interview. And I think not being careful there and also combined with some of the existing limitations of the model could be really problematic.
Yeah, and I guess on a lower level, you've done some research too on the extent to which these models are bad at certain types of tasks, like moral reasoning. It seems that they can be pretty bad relative to other things, right?
Yeah. So I think a lot of the reasoning literature, if people in the room are probably familiar with chain of thought and more complicated reasoning, is very focused on math and logic reasoning or common sense reasoning. And I'm working on more focus on the social reasoning or moral reasoning as research focus, because some of these problems are not as black and white. It's like, is it okay to lie? Current benchmarks usually will say like, no, according to the common norms of US 2020, it's not okay to lie, and you score the model based on the accuracy of the multiple choice questions of yes and no. But in your daily situations, there are cases where it's probably okay, or it depends on your intention that it's not that black and white. So I'm working on some of these more less accuracy defined kind of areas and figuring out how to evaluate it more robustly and improving models' capabilities on some of these more ambiguous problems.
Yeah, super interesting stuff. So to circle back now to this question about the pace at which the models are evolving. So I don't know, maybe because I'm a social scientist, I think a lot of people in this room are social scientists and or statisticians. I have a strong interest in studying LLMs and generative AI, and I'm constantly stressed because I'm like, well, I run a study today on GPT-4, and then tomorrow there's OpenAI Dev Day, and all of a sudden there's GPT-5, and now who knows if my results are even valid anymore? I need to rerun my study, and so I'm curious, I guess, like Payel and Xiao, like as people who kind of are involved more in the design and building of these models, like do you feel the same level of, I don't know, like existential stress that we feel trying to study them? Like, do you feel like the ground is moving so quickly that it's hard to even know what's going on, or is that something that we're only perceiving on our side of the chasm?
No, I mean, the way I view it, that if LLM is a learner, if it's a learning agent, right, and that's the main role, and from that it can do, reasoning or, this planning and decision making, as like high-level tasks, and also some other low-level tasks, which we are mostly exploring as of today. I think a key question of learning is how to quickly update your learning, right? And as we do the research on the algorithm side, that is a challenge for us, that like let's say tomorrow GPT-5 is coming up, that is it because some of its core inner working have changed, or because there is a big shift in data? And that's what we are hearing, right? That some of the LLMs that have been trained on copyrighted data. So now there is going to be a new model launched tomorrow that is more on the cleaner data. And then we hear the launch of the closed model, which is being trained on some of the inner source data or client data that we don't even get to see. So there is some form of opacity in there. The point here is that how quickly we can update our language model or someone else's language model as we do see a new release of data, if we assume that the core architecture is unchanged pretty much, right? We keep it intact. Our body mechanism is not changing every day. We have a pretty standard basis there. So that is, I would say, a big challenge, and that's something I'm personally working on, that how quickly a language model can update its own experience, and from that it can start taking new action based on some of its own past experiences. And if you think that could be, the experience could be just data, the experience could be just prompt, or some of the recent interaction with the environment. Yeah, I think that is something pretty exciting, and as we learn from our day-to-day operation, to lie or not to lie, all of that changes based on the context, based on the environment. It's never a static frame, and I think to have that dynamics inbuilt into the large language model as they act in the real world is going to be crucial in the coming days. And that's probably, if you know that you can update it quickly, going back to your question, you probably feel more confident that I'm not working with a static point, rather I can update it easily, low cost, as I, try to replicate my my study from yesterday to today, or probably bring in my own set of new data.
Yeah, that makes sense. I guess, Brandon, I'm curious if you've thought about this, because I know you've looked at how accurate are these models at certain types of questions that experts can answer. And as the models get better, it's like, well, is this paper now just irrelevant if all of a sudden it's more accurate 30 days later or something like that?
It's a wild thing. I mean, I coming from having been trained in political science and working in sociology, the timelines to publication are, I just had a paper came out that we wrote the first draft of in 2019, and that's not unusual, right? That's a typical thing. Right, it's not bad. So the issue is this paper you're talking about. So this is a study we ran where we got 10 experts in very diverse fields, from like ballroom dance to neuroscience, to write questions that they get asked or that are asked in their field. We generated LLM answers, and then we had them sort of evaluate. And we're trying to assess sort of expert assessments of information seeking. It was essentially the idea. And we submitted this to the Association of Computational Linguistics, and the submission, we ran the study in like January 15th or something, and ChatGPT had come out November 30th, right? So this is like wildly fast in some sense. And yet by the time it came out in the conference in July, August, you had GPT-4 had happened, like all these, all the llama models had come out, Falcon, like all these things had occurred. And so, it's like, is this creating generalizable knowledge at this point? And I think I really don't know the answer, but it sort of pushes us to think about like, how can we frame these things in a generalizable way, which probably pushes us more towards how do we measure the core properties well, as opposed to necessarily like, if we think on like the safety side, as opposed to like mitigations or something, right? Like you end up, because the mitigations will change, but the measurement hopefully will be constant. And it makes us think about procedures that are going to be stable under various changes. So that paper, we were trying to get our heads around it, but I think we didn't quite appreciate how fast it was moving. And I will add to your existential worry. Another thing that I worry about a lot that I think is particular to these generative AI models, but is you can be working for many years on doing something. So we have a long-running project with collaborators on analyzing police body-worn camera footage and trying to understand escalations into violence. It's very complicated data to get access to and to work with. And I sort of live in terror because it's just like any day, one of these large tech companies could drop something that just zero-shot outperforms a thing we've been custom creating forever. And that didn't used to be a risk, and in some sense it's great, right? Your problem might just show up and be solved, but it's also a little terrifying.
I have some projects where I have the exact same feeling, so I know where you're coming from. Daniel, I guess, so you have been studying AI, the economic impacts and implications of AI for a long time. And so you were saying last night, you've been through multiple different AI sort of cycles. And I think, within those different cycles, I'm sure people have always felt to some extent, for instance, with deep learning, oh my God, there's a new deep learning model every week. Like the benchmarks are constantly changing. Arguably, maybe with this LLM wave, it's a little bit faster than it has been in the past. But you're familiar with trying to do research when things are changing so quickly. So I guess I'm curious what your perspective is, and does it feel different this time relative to these previous times from your perspective?
Yeah. I mean, certainly on the last point, it's moving faster. But yeah, I remember maybe it was the first code, and there was an argument between Jeremy Howard and some others that with enough variables like correlation and causation, it was an irrelevant question. This is and that we were talking about random forests back then, right? So different stuff. So yeah, I think we're probably in the third wave of econ of AI stuff since I've been looking at it, and it goes back many more years than that. But I think, and this is the same thing I would tell most businesses, like not Google or IBM maybe or OpenAI, but most of the time you don't want to try to build the better mousetrap LLM, that you're competing with people who are really, really good, and there's 3,000 people in the world who are super talented at training these types of models. Yet if you sit 10% back off the frontier, you can deploy stuff that customers still think is magic, and make it modular, keep deploying the latest and greatest stuff. I think for researchers, especially on the social science side, that's our job too. Think about the core questions where we have a comparative advantage. And I'm looking around the room, seeing people who Madhav and Dean, your paper on estimating complementarities or substitutes, right? And then using that to bootstrap experiments. So I think that's sort of foundational machine learning work that you can convert into really good social science questions. And that's independent of the method. You could build better methods, but it's useful. Well, wait, I should check. None of my future students are in the room right now, right? Okay, because I'm running an experiment on you next semester. So, there's this question of how much is GPT changing, learning rates and learning quality. So one of the things that I changed in my syllabus is you don't get points for just being correct on your memo assignments anymore. They write a 2-page memo. You get points for being correct and original. And original is defined by distance from ChatGPT in some sense. So there's a new incentive structure that goes in here. And one of my colleagues and I are running this experiment to see if that incentive structure change creates differences in learning outcomes. Now that doesn't matter which GPT we're calculating against, but everybody kind of knows I can use GPT to do stuff. By the way, from my perspective, if you can trick me and it's you still use GPT, but I said you were original, great, you learned a valuable skill. You're threatening me with a good time. So this is the sort of stuff I think we care about incentives, or economists, so incentive design experiments kind of thing we care about. That doesn't matter what model it is. So race with the machines, as they say, not against them. I think that's the best advice. But of course, my other paper, we're gonna have to update that in 2 weeks or 3 days, whenever the next model comes out.
Yeah, totally. I guess so. We've talked a bit about trying to do research in this landscape, and of course, many people in the room here, do some research, but they are paid by an entity that is not about doing research. It's about making money, I guess. And so I'm curious if you all have thoughts on if we're thinking about online platforms, online marketplaces, businesses of different types. Like, what are some of the LLM impacts or changes that we might expect to see in the next few months that we haven't seen? So from like the perspective of someone who's building the models, or from someone who's analyzing their economic impacts, or even as a sociologist, like how do we think that these models are going to impact the economy, society, just more broadly outside of can I get my paper published, which is something I think a lot about, but maybe some other people don't.
Can I
Yeah.
add on the research point? I think people dub the OpenAI Dev Day as the Red Wedding for some rapper startups, which I think is interesting. And then people, talk about moat and all that stuff. And I think for research, there is maybe for me also the concept of moat, in that the classic research is about fundamentally understanding human behaviors and human incentives and how people interact with some of these technology, regardless of how some of these technologies shift and how fast they shift. Some of the social media age research, a lot of people go back to very classic sociology studies, and I think there is some value in designing the studies to be not chasing whatever is the fastest or whatever is the latest, but thinking about the fundamental research problems and what long-term research could bring, rather than just like quick payoffs. And then in terms of the applications, what I find really interesting is how people are leveraging some of these tools to kind of like Meta, we're doing that for research, using these language models to accelerate research. People are using these tools to try to build and iterate applications, consumer applications and business applications. And there is also probably a lot of them also have existential risk of like, what if someone just like build this thing and then our thing will be obsolete. But there is this space, I think, in co-designing the backend and the front end that more seamlessly work closer together. That's really interesting about thinking the user interactions between the language models and the applications and how people want to interact with these. And it's because of the speed, you can iterate faster, and the internet or everything is like, if you iterate faster, you get better products. So I'm really excited about seeing products especially the pace of innovation in the space pick up. Yeah,
no, I think that seems really interesting. I mean, I do wonder, I think Daniel was alluding to this with his students and their submissions becoming more similar, but I feel like some of the studies we've seen in the Payel sessions and just more broadly in the literature show that when people use these tools in various types of tasks, their outputs become more similar. They kind of converge on, sort of what, the LLM would suggest. And so, in certain business applications, you might think, well, having a bunch of different stuff is good, and maybe if everyone's doing the exact same thing, that's not good. But the speed benefit does seem quite large. Curious if anyone else has any thoughts on this topic of just what the broader, where might we see these models in the world, in, existing businesses, new businesses, other facets of society?
I think it's almost everywhere. I think it's touching everywhere, some places more and some places less. And also I think the goal in some cases is more on the creative side, and some other cases it is more on the deterministic side, where we are more satisfied to see the consistency before what you used to see before. And of course now in terms of accuracy, in terms of speed, it's much faster. But on social science of thinking, right, the application, I think one particular aspect there is more appreciated to see more creativity in terms of annotation, in terms of like story writing and stuff like that. And also some bootstrapping the creative generation task, maybe by showing the model's confidence, maybe by asking the model to explain its own generation. I think that's pretty interesting, because if we look back in the past era of machine learning, deep learning models, that was not so seamless. They were coming out with prediction, some maybe generation as well. But this I think the added thing that in terms of model confidence, the model explanation with what the model is asked to do is a new thing, and that's touching many areas, I would say very positively. At least that we know that that's a need now from this technology.
Yeah, no, I mean, I think it's interesting. I mean, I agree that, and this is just my perspective, obviously, that in some sense the models seem super pervasive. But I think if you had asked me 12 months ago, I guess, when ChatGPT was released, what's your belief about how prevalent this will be? I think I would have expected to see much more LLM stuff in my life by now. So we've seen this implemented in search. Obviously, a lot of people use ChatGPT for various things throughout the day. But if I'm thinking of, am I buying things on Amazon by, just typing to a large language model like, hey, I need to buy some socks that are comfortable, please buy them for me or something. Like, I haven't seen so many of these use cases throughout the world. So there seems to be some, people are figuring out the right implementations, or there's some friction, or maybe in a lot of areas there is some human favoritism. But I guess I'm wondering, like, where do we think this is actually going to change things, and what areas might actually, sort of continue to just be more similar to the status quo world in which we've been living?
Yeah, I was at an industry conference earlier this year, and the COO of Cohere was up there, and he said, okay, everyone in the room, raise your hand if you can use ChatGPT or GPT at work. Actually, let's do that now. And in the room, who uses GPT at work right now? All right, so when we were asked that question, just about everybody, right? When we were asked that question, my hand was the only one in the room that went up. They're all industry folks. And the reason for that was all the general counsels banned it. So if you're thinking about frictions, there's like an explicit friction in many companies. Just straight up, we're not willing to take the risks associated with these models, and they haven't been properly documented. I mean, there are some really scary risks out there, like prompt injection, especially with the latest stuff with like code interpreter. You can recover some like proprietary files if you're not careful on that stuff. Certainly when you think about art, like the copyright liabilities there. I mean, I think there are engineering solutions for these things. They're just going to take a while. And this goes back to the old, econ management IT stories about, general purpose technologies. When they come out, they require a lot of complementary innovation. They spawn a lot of complementary innovation. There's business process systems that have to change, new ways of understanding, like how we train people, all this stuff, comfort with the models. That takes a long time. And I think it actually eroded a ton of value at the last wave, like deep learning. Everybody promised all these great gains, and then consultants come in and they have limited ability and capacity to actually change stuff because people are worried about risks. So I think there's a lot of reasons for that. Some of them are more social and not really economic. Like there's clearly an application, it'd be valuable, and then there's someone telling you it's going to steal your job or something like that. And that blocks a lot of the diffusion. But also we have a legal system that really puts a ton of risk on you if you're trying something new. So we'll figure it out. It's just going to take a while.
Yeah, and sorry.
Yeah, I was gonna say, for me, it's both the model's robustness is still lacking, especially hallucination is still a pretty big deal, in addition to some of the security issues. It's because these models fundamentally are probabilistic until we have something that's like more breakthrough in some of the grounding techniques. I think that is a major limitation. And then another aspect is more on the interaction, is we had computers, we invented GUI, graphical user interfaces, for a reason, because they're user-friendly. And now we're going back to natural language interfaces, but some of these tasks could benefit from some GUI assistance. So people, I think, are still, because like you scroll back and forth, there's a wall of text, and you copy and paste. And so I think people are still figuring out how to combine the latest natural language interfaces again with the GUI interfaces. And then I think that's just needs time to kind of iterate and test, and people also learning and getting used to that.
Yeah.
And I think another point there is that the confidence is lacking because there is still a lack of governance structure around this model. Going back to your example, that if your student makes an error by using ChatGPT, is it enough for the student to come and say, because I use ChatGPT as a reference and That's why I'm wrong, or is it my own responsibility? But if he shows you a book where this wrong statement is there and says that, okay, this is something I'm referring to, maybe you will give him a benefit of doubt or some credit that it's an established source of knowledge where this wrong information is there, so it's not the student. But I think for ChatGPT, the same notion is not there. Yeah. Or ChatGPT or similar, right? That who takes the accountability if something goes wrong? So, and this governance structure is not going to be one size fits all. It's going to be user-defined governance. It's going to be a governance that is more for the broader society, depending on the demographic. This governance structure is going to be changed. And as long as we don't have a clear idea of at least some basic format of it and some accountability around it, it's difficult for the broader society not just to, I think, try it out, that's happening, but using it reliably as a reliable source, as a reliable tool for day-to-day job is going to be lacking.
Absolutely. I think this is a good moment to get some mics going around the room if folks have questions. But Brandon, I saw that you were trying to say something a few times. So
yeah, no, I mean, it's obviously a good question when everyone wants to jump in. And I would just say that I think that the trick for adoption in the near term are going to be things that are checkable and people perceive as doing it as a nuisance. So you think in the context of education, for example, like something that everyone's familiar with, I teach statistics and programming to folks that sometimes just like want to get the task done and don't like want to further develop themselves as programmers. This is great for that kind of thing because you can, the tools are relatively robust around programming and it can produce solutions that can be checked, but you don't need to like deeply understand how the program works necessarily. But as soon as you do need that, it becomes very complicated. And I think we're pretty far away from like robust notions of interpretability. I mean, we can ask an LLM like, why did you do something? But these systems are, they're sort of explicitly designed to fool us, right? And so there's a sense of like, there's no guarantee that is anything close to why the system did the thing. And so there's going to be cases, and this is sort of what I mean by the task itself is a nuisance. It's like, maybe we don't care why it did it as long as it did the right thing. And so in the short term, that's going to be the thing. But to move into broader settings, I think we're going to have to really understand why it's making the decision, or the accuracy is going to have to get way, way, way higher.
Yeah, makes a ton of sense. Is there a question in the audience?
Yeah, thank you for kind of discussing particularly about kind of offline measurements and kind of how do we approach measuring these LLMs. And I'll disclose my bias here. A lot of my work recently has been about evaluating LLMs in experimentation and online settings. So as we think about these offline evaluations, many folks in the ML community are saying we're kind of saturating these benchmarks. And really, in order to test these human-like abilities, you kind of really need to go to kind of this generalized user input where you're testing at large scale. So how are you approaching testing these LLMs at large scale? Are you thinking about online experimentation? How do you enable the experimentation in a way that's kind of safe for the user, but also give us, eventually these are going to be in products, and they are in products right now. I'm from Microsoft. So how do you approach thinking about evaluating them at large scale while kind of maintaining these concerns that we have around safety and accuracy and kind of really satisfying the user need?
That's the question for me. Yeah, I don't know. I mean, I can go first here. I think that the one aspect of past evaluation was that it used to be very monolithic. And now we are in the era, right, and that we know that one metric, one measure of performance is not enough. And to your point, that even us, when we are working on LLM and we are talking about like what I was saying about this control experiment, right, the controllability, as we look into the LLM benchmark, there is actually a lack of a task, even for that particular scenario. You can think of, okay, maybe I take a bit of this, some in a light task and something else. I can come up with a hybrid, but that's actually not even representative of this task. That's one. And the second thing is that these LLMs are going to interact with the user, will interact with other LLMs, and so it's going to be a human AI collaboration. And for those scenarios, there is not many tasks. There are really no many tasks. So I think there is going to be really a lot of investment in terms of gathering data, which will simulate or represent these newer tasks, these newer challenges that we are seeing, and come up with the right metric, right measure. So I think that's we have been now seeing we have seen that the importance of clean data, the importance of data duplication, and we start to see that the lack of evaluation benchmark, and also how we measure models' performance on a particular benchmark. If we are just showing mean rank, is it really informative? Is it, should be reweighted by the importance of the tasks that are more aligned with where I am going to launch my model, or just, showing the mean rank across 60, 120 tasks is enough? So I think these are really important research questions before the models are, these technologies are more integrated into the product platforms.
I would add that probably people in this room have a lot of expertise who are all running experiments across different large-scale platforms. And I think to circle back on David's comment about why some of these language models applications in the real world may be still lagging, I think some of these models have amazing performance on large benchmarks, and I'm sure people who work on evals know how challenging this is. But when you put them out in the real world, it has things that you have actual users, you have different scenarios, so that's like a different measure. And I think a lot of the learnings from previously social media companies, large-scale experiments, and also a lot of the large platforms that people in this room probably have a lot of good ideas of how to apply some of what we know about online experiments once we have the actual users coming online and optimizing, iterating on some of these designs. What I want to, I guess, highlight is also throughout designing the experiments and large online experiments with human subjects, we also made some mistakes in the past in doing experiments with human subjects. So I hope that we can learn from the experiences and do better this time. But yeah, it's all kind of in progress.
Yeah. Is there another question over here?
Yeah, thanks so much for the discussion. I guess I have a very question regarding, just to follow up with the replication perspective of the data. So not sure if you heard about the Mario-Luigi effect of using LLM model. Basically, it's in the game of Super Mario. There's the character Mario, and there's also the character of Luigi. Sometimes you think the LLM is producing you the character of Mario, but instead it produced Luigi. So it's kind of a hallucination while doing prompt engineer with LLM models. So in terms of designing an experiment, or especially those online large-scale experiments with LLM, I'm just thinking, what do you think could be a good approach in terms of solving this? Because what we're approaching right now is we have a really long list of prompt engineer, the keywords. It's getting really lengthy with the moving progress of the experiment being deployed and everything. But in the long term, I see this is not only costly, but it's also creating a little bit of a trouble when replicating the results from the experiment. So what do you think about this? And what's a good way of making sure the data is replicable and also sustainable? Thank you.
Yeah, I had not heard of the Mario-Luigi problem. Imagine if we got Wario and Waluigi as well. It could get really bad. Yeah, I'm curious if anyone has any thoughts about this. One thing I've thought about in this context, which I think is maybe different from this, is even just using LLMs as scientific tools. Replicability is a huge issue. You can't really set a seed necessarily in the way that we do with a lot of other techniques. And so if I'm using the LLMs to produce some data for my analysis, and someone, a reviewer wants me to redo something, I kind of need to start from scratch. But that's kind of distinct from the question of just, when I'm using these models in various capacities, are they really doing what I want them to do, or are they producing some, very good facsimile that's maybe different in important ways that I can't necessarily observe?
Yeah, we faced this a little bit with some of the stuff we were doing, and I think first thing to recognize is that prompts are brittle. You have to try a few different prompts, and then you have to try the same prompt multiple times in the same context. And maybe you don't replicate exactly the results you got from one iteration, but usually you get some sort of normal distribution thing, or contingent on whatever the prompt is. So when you start to see that convergence, when lots of sort of similar but slightly different prompts create the same thing when you run them 50 times, then you're in better shape. But that's a real shaky kind of thing. I think GPT-4 is trying to, or OpenAI's got this like replicability mode thing that they're putting out there. They recognize it's a problem. I don't want you guys to get in trouble for stating anything that may or may not exist, but if Google or IBM's working on similar stuff, that'd be cool too. Or any of these places like that. That's really helpful for deploying these tools in research.
Yeah, and I think the choice of prompt, it also comes from our own cognitive bias. Even within my team, when we try out some model or we're testing some model, right? Our own, some cases algorithm, each person will come and say, okay, this is the prompt I used, and they have their own way of justifying why they used, and they could be very different. So I think there is going to be a science around also prompt, that how similar one's prompt is from the different, from another person, and how this is being mapped to language model output. So to some extent, if the prompts are similar, and if this prompt can be mapped to a particular persona, for example, right? So we know that the language model is receiving the same persona over and over within this distribution pretty consistently. But if it's a very different persona, then it is reacting differently. And we all have to make sure for some fact or some ground truth knowledge, no matter how is the persona changing over time, that the language model output is going to be same. So it can rediscover the same fact again and again, no matter how variable this prompt is.
Yeah, to just quickly build on what you were just saying, to plug my own work, I guess. I'm working on a project with a bunch of folks in this room and some other collaborators as well, and we're trying to understand prompting behavior and looking at just different people and how they prompt. And we're only in the piloting stages still, but we're seeing some really interesting differences in terms of how people in different age and gender and educational and occupational background groups write prompts to try to achieve the exact same goal. So I think there is a lot of the cognitive biases that people have, and just their different backgrounds really inform how people are going to interact with these tools to try to achieve the exact same goal. Brandon, it looked like you had something.
Yeah, I was just going to say to the question, particularly about like how we think about replicability and stability. I think the first order question is really whether or not we need that at the individual unit level or not, right? So, if just to take a really old, simple example, if I'm using like AI to do a spam filter, and David's invitation gets like chunked into spam and I never get to be on this panel, I'm like really upset. Like I really care that each individual email is correctly classified. But if what I'm trying to do is estimate the fraction of emails coming into different people's inboxes that are spam, then I have tolerance for individual level error, and I can sort of focus on that particular quantity. So I do think that there are going to be times when, even when we can't address these effects at the individual unit level, we can address them really effectively in the aggregate.
Great. One other question over here.
My question is to build on the discussion about the speed at which things were changing. So on the panel, it seemed like we discussed that it's hard to know if scientifically these models are effective. Do you think that will create a future where the economic value of particular applications will determine the success of their models rather than scientific functionality?
I mean, the short answer, for sure, right? Like the economic value is, I mean, sorry, I'm showing my biases here, but like the technological capabilities are always overlaid into our own utility functions for what we're doing here. I think you see this with some of the scaling discussion too. Like everyone's like, oh, they have emergent properties, these models. Like there's, all of a sudden they're great. But it could very well be that the scaling of the model capability in mathematical terms is like perfectly smooth as it goes. And then there's just some spot in the loss function for training, in our own loss functions for like what's valuable, where that's discontinuous. And it's like, oh, okay, now this doesn't create nonsense that the model's like, I don't know, that looks like nonsense. This looks like nonsense. The model's like, it's just slightly less nonsensical. But for us, we're like, no, that's a great Taylor Swift poem that you just created or something. Like this is, yeah, I bring that up because I converted Taylor Swift lyrics into Led Zeppelin lyrics. And if you put the temperature up too high, it's garbage. But as you kind of inch it down, eventually it like flips into something you could see Led Zeppelin doing. And it's like our utility functions are shapes of those things. This is where behavioral scientists have a lot of work to do, and it's going to be really cool to see what they pull up. There's starting with algorithmic conversion, but then moving on into, are our preferences lexicographic versus continuous? Do we have these like superordinate preferences? Just saw a really cool paper presented about that. Like there's all sorts of really cool behavioral questions we can get at using LLMs. But yeah, I think the economic value drives like how quickly they diffuse for sure.
Yeah. Saw another question over here.
I think like a lot of our conversation in this conference today are like we're running online experiment with humans, and also like in this conversation we talk about like using LLM to do annotations and all those kind of stuff. This just reminded me of a work that I read before that is like saying probably around 40% of online crowd workers, they're actually using LLMs. For example, like you're trying to collect some information from online MTurk workers, but they're using LLMs. So this sounds somewhat like a data contamination kind of stuff. It's like you're trying to collect information of humans. You want to know like real human signals. But now with LLMs, you're kind of getting these noisy LLM mixing signals. So I do think this might kind of like be a problem, especially like for social science researchers. So I just wondering how people think of this. What are like some of the possible ways you consider with this kind of problem?
Yep. Can I?
Yeah.
So that is, I think, one of the hardest parts of evaluating. Is sure we can, end of the day, try to do a human evaluation. I think there are researchers asking prolific workers of, do you actually use these models? People say no, but there's probably also a selection bias of who choose to respond there. And it's unclear if that's the truth. And so I think there are probably, I'm thinking both technical and also just in terms of design of the experiments on two types of approaches. Technical ones is there are research on algorithms based on the probability to detect or watermark some of these responses. So some of that work could be very valuable, and you can imagine detecting or adding some detection to that. And then on the other side, there is also the idea of human in the loop, human ML collaboration, in that maybe designing of these tasks, just assume that people have the availability of these models and maybe design better assistance for the people to perform the task where we need their creativity or what humans do the best, and to design the collaboration rather than kind of the traditional annotation task. And figure out where the language model's abilities excel and where human input could really make a difference. I think that would be something that's super interesting.
Yeah, I mean, one thing that I've done in my own work and that I've seen other people do is trying to put timers on certain questions so that you reduce the probability that someone's able to, tab over to GPT-4 and like type things in. And then apparently you can also disable copy paste in certain browser windows if you're running like Qualtrics or prolific studies. But these are all band-aids too, I think.
Copy paste is the other possibility, right? You let them do it, and then you know after the fact.
Yeah, but these are all seemingly band-aids on what is a very profound challenge to doing social science research.
Use prompt injection too.
Yeah, you can use prompt injection. One thing I want to ask before we run out of time, and I think I would be remiss if we didn't talk about this, and Brandon, you talked about this earlier, is we are ultimately at the Conference on Digital Experimentation, and there's a lot of opportunities to use these models, not just in analyzing data or in as a subject of study for digital experiments as we currently conceive of them, but as a way to entirely rethink how we might conduct experiments. And I think there's some work in some of the parallel sessions later today that touches on this a little bit, right? So the idea of perhaps using LLMs as agents to kind of simulate experiments that might be expensive or might be unethical to run on humans. As Xiao pointed out, though, maybe we don't necessarily always want to trust the results that we get from these models because they're maybe not trustable on certain things. So I'm curious, do people have thoughts or ideas on how experimentation might just be totally augmented and different in a world where we have LLMs and generative AI?
Yeah, I can probably take first pass on that because we did run some experiment where we asked generative AI to come up with some valuable and novel design of molecules with particular functionality, be it antibiotic or antiviral, right? And then we also use another generative AI engine to show how they could be made. And all of them then were dumped in the plate of human experts, because they have to make the last decision that which one from there goes on to this study where they will be made and tested to see that if what the AI generated is really holding, if it's really can be verified that it does what it was supposed to do. And what we find that when we are using generative AI, one thing that all experts they were really happy to see is the creativity of this model. That with their experience, with their knowledge, they said that these designs they wouldn't have thought about. So that is the positive side of things, that now we are starting to explore the landscape that we wouldn't have thinking of doing that. But then when we, let's say we are dumping 100 designs in their plate and we can only take 10 from there on, that's where we find the human expert evaluation comes really handy, that the ranking model, particularly for novel designs, are not so good. And it goes back to the generalization problem of that these models do have, that for the new design that is far from the original space, while it is novel, while it is showing the value, but which one would have better value than the other? That's where human feedback comes really, really useful, as well as like when we show them different experiment design choices, how each of these can be made. They take some of it, human expert, but not necessarily go by the book that what did AI recommend. So I think this is like one really good, cool notion going forward, that where AI is coming up with new experiment design, new hypothesis, but then human experts are coming up with their own knowledge, own prior experiment, and it's a win-win. So in all of these 2 or 3 different case studies we did, in each case, the expert acknowledged having AI in the loop, having AI being able to do something, but they also appreciated the fact that they are the one who is making the last call, because it's also because language models or this generative AI do have limitation based on the data that they were trained. And typically the experts, sometimes it was difficult for them to express why they're canceling or ruling out this option versus the other one. But at the end, they were right.
Yeah.
I guess I'll add, I think there's a lot of opportunities. There was a lot of debate in the 80s and 90s in the style of experiments between open-ended and close-ended. And close-ended items largely won that just because doing open-ended was a pain. And I think that there's a sense of like, first there's just the classic like text analysis thing. We can sort of let people say what they want to say. But I think there's also ways in which we could really improve best practices of surveys by sort of allowing people to ask clarifying questions, pressing for follow-ups in ways that could be done by an AI agent that I don't think is quite as difficult as, say, having like a full AI interviewer. And I think those add some real potentials. But even that is just kind of taking a thing we would do if we had more time and sort of adding to it. And I think we haven't yet hit the space of like real like doing something just radically different. But I'm excited for when we hit that point.
Yeah, I think it's one of these things where I think we all have a sense, some latent sense that there is something that will come about, but we have not yet figured out exactly what it would be, because if we knew, we would be doing it. Exactly. But I have no doubt that it will probably be in this room in 3 or 4 years, or probably sooner, given how quickly things are moving. With that, we have time for one more question, maybe, if there's a microphone that's kind of floating around.
Hi. So as these models become more and more pervasive in our lives, how far away from a version of the base models where we begin to have feedback loop in the training data, or where that might become a problem? And like, how are we thinking about solving that? Is it about just scalably tagging human-generated versus AI-generated data? How are we thinking about that?
Big question. We have limited time to answer it. So if anyone has a couple of sentence long hot take on on Wen's question.
Oof.
I think it goes back to the evaluation points that we're talking about. It's probably already here for to some extent, and we probably don't know what extent it's causing problems, and probably more work to be done there. Yeah.
Cool. Well, we will leave things on that cliffhanger because we are standing in the way of everyone in lunch, and that's not a good position to be in. So let's thank all of our panelists again. This was a really amazing discussion.